Hi everyone, this is Mishal Salim, and today we are going to answer a question which is um, from where did the quadratic formula come from? Or let me rephrase that. How can we derive a quadratic formula? So for that, first of all, we need to write a quadratic equation in a standard form, which will be ax squared plus bx plus c equals 0. So now this, first we divide both the sides by a. So let's divide both sides by a. As the coefficient of x squared is a, that's why you need to divide both sides by a. Okay, now this a will be in division with all of the terms, so it will be ax squared over a, then bx over a, and then plus c over a equals 0. So now in the next step, we're going to move this CA, the constant part, to the other side, and also this A and A got cancelled, so they got cancelled, and now we get x squared plus bx over a equals negative c over a. Okay, now in the next step, we're going to divide this by 2 and then square it and add it to both sides. Let's see that. So if we divide this by 2, it will be 2a. Okay, so x squared plus bx over a, and then the coefficient of x is b over a, and when you divide it by 2, it will become b over 2a. Now square it and then add it to both sides. So the square of b over 2a added to this side, now also add it to the other side, so it will be c over a plus b over 2a and then whole squared. Okay, now if you look at this part, so this is a formula. How this is a formula? Let me write it down here. X squared, which is first squared, and then plus the second squared, and then plus 2 times of first into the second, which is b over 2a. So it is actually, you see, a squared plus b squared plus 2ab, which is equal to a plus b whole squared. So now you see 2 and 2 can be cancelled with each other, so we get bx over a, which is here. So actually they are both the same. So this is the formula. Now I'm going to write down this formula as a complete square. So it will be then x plus b over 2a, b over 2a whole squared equals, okay, this one here is negative c over a, and then plus it will be b squared if I apply the square, and over 4a squared. Okay, so now in the next step I'm going to add these two fractions. So the LCM of these two would be, you can do it by LCM, or you can either do it by making the denominators same. So what should I do to make the denominator same? So this is 4a squared, so I must multiply 4a with the denominator as well as with the numerator. Okay, so here now this is 4a squared, so I will just write 4a squared here, and then it's negative 4ac b squared and negative 4ac. So b squared and negative 4ac. It's actually negative 4ac plus b squared, like this. Let me write it down here. It's 4ac plus b squared. So we can write it the other way around, like b squared minus 4ac. They're equal. And now in the next step, I'm going to take square root on both sides to solve this equation for x, to find the value for x, or you can say to make x the subject. So now let's put square root on both the sides. Okay, so this side got cancelled, and we are left with the x plus b over 2a equals plus minus, as whatever comes out of the root is positive and negative, b squared minus 4ac, and if we apply the square root to separate to both of them, so the square root of this is again b squared minus 4ac, and this is a perfect square, so I can write it like 2a whole squared, and then take square root on it. So square and square root got cancelled, and we're just left with 2a. Okay, so now as we are making x the subject, so now we will shift this b over 2a to the other side, and let's shift it. So now this is positive b over 2a, then it will become negative b over 2a. And plus minus b squared, oops, there is a c with it. Okay, so 4ac, and then over 2a. So now these are two fractions, and either in addition or in subtraction. So whenever we subtract or add two fractions, we must make the denominator same, which are already same. So then we can add or subtract the fractions. So let's see the answer. It will be negative b plus minus under the root b squared negative 4ac